All right, when you're going through these problems, make sure you draw and label a triangle. Back in Unit 8, remember when we did this forwards and I said you have to draw and label a triangle? That's like your work. Same thing here, just make sure you draw and label a triangle. First thing we're gonna do is state the quadrants where they're allowed to be. So they're all gonna be in 1 and 4, except which two? Secant and cosine. So arc cosine and arc secant, those are the even ones. They're in 1 and 2. All the rest of them are going to be in 1 and 4. So 1 if it's positive, and then whatever the other choice is if it's negative. So the two even ones, again, cosine and secant, those are in 1 and 2. All the rest of them are in 1 and 4. So you're very, very restricted on where your options of where you can draw a triangle are. So for number 7, for arc sine, your choices are quadrants 1 or 4. It's negative, so it's going to be 4. So draw yourself a triangle in quadrant 4. Sine is the y value, so that's where the -1/2 goes. And what is your angle across from a half or negative? Pi over 6, good. Now pi over 6 is not your answer though. What you want is the amount of rotation it took to get there. So since we went backwards, what will we put? Negative pi over 6. If you're in quadrant 1, whatever you get, that's just your answer. If you're in one of the other quadrants, just remember it's the amount of rotation. You do not have to draw the arrow. That's just me illustrating. Arc cosine, and it's negative. So what quadrant is that going to be in? Good. Draw your triangle in quadrant 2. Cosine is the x value. So that negative square root of 3 over 2 is the x value. That means that the other side has to be a half. And so again, the angle across from a half is pi over 6, but your answer is how much you rotated to get there. 5 pi over 6, good. And things like that are the reason why I made you fill out so many unit circles, so that like comes to you a little quicker. Arctangent of 1 is tricky because doesn't 1 make you think of like the up, down, left, right? Okay, but whenever it's tangent or cotangent, that's not the case. This is positive, so we're in quadrant 1. Tangent is y over x. Anything over itself would give you 1. So what does that mean both sides of the triangle have to be? It has to both be the square root of 2 over 2, which means your angle is pi over 4, good. And because you're in quadrant 1, it's just pi over 4. When you're in quadrant 1, everything's positive and whatever you get is just your answer. So quadrant 1 is great. All right, number 10, arc sine, and it's positive. So we're in quadrant 1. Sine is the y value. So that's where your square root of 3 over 2 goes. And so what's your angle across from that? Pi over 3, perfect. And that is your answer. Now, when you have arc secant or arc cosecant, I would do the reciprocal. That's my suggestion for you. Your reciprocal of secant is which one? Which trig function? Cosine. So I would write this as arc cosine -1/2. Just flip it over. You're doing the reciprocal. Sine and cosine are more familiar to us than secant and cosecant. So that's just my suggestion. Okay. It's negative and we're looking at arc cosine. So what quadrant would that put us in? 2, good. So draw your triangle in quadrant 2. Cosine is the x value, so the -1/2 goes along the x-axis. That means the other side is square root of 3 over 2. And so what's your angle across from that? Pi over 3. But your answer is how much you rotated to get there. So think about your unit circle in quadrant 2. How far did you go to get there? Perfect, 2 pi over 3. This one's positive, so that's quadrant 1. And it's your square root of 2 over 2, square root of 2 over 2 triangle. And that means your answer is what? Pi over 4. Is that one, like, I hope I can say this, is that one that you could almost just do in your head? Draw me a triangle anyway. I'm going to count it as the work. Okay. Now for this one, if it's arctangent or arccotangent and you have that square root of 3 over 3 or just the square root of 3, I would write this off to the side. Like, let's go up to the top here and just write this in the margin of the paper. When you get your test, just put this on your test. If it's square root of 3 over 2 over a half, what is that going to reduce down to? Good, square root of 3 over 1, which would just be square root of 3. And if it's the other way around, the 2's would cancel. You would get 1 over square root of 3. And then that would rationalize to square root of 3 over 3. I would just jot that down. Just jot down those two things in the margin of the paper when you get your test. Because now when you go to do it backwards, you can just look back at that and see what you have. So looking at this one, first of all, it's negative. So what quadrant are we in? Let's decide that first. 4, good. And it's, I know it's negative, but it's square root of 3 over 3. If you take that backwards, you get this. Tangent is y over x. So y is going to be the 1/2. X is going to be the square root of 3 over 2. And one of them is going to be negative because it was negative, but this is y and this is x when you take that backwards. So the 1/2 is the y, that's the one that's going to get the negative. Square root of 3 over 2 is the x. And so what's the angle across from the 1/2? Pi over 6. But your answer is negative pi over 6 because you rotated backwards to get there. If you're like, I'm scared I'm gonna get that backwards, Miss Cole. All right, look, I think I made them all 3 points each. If you wrote it the other way around and got negative pi over 3, I would take off half a point. Do you get what I'm saying? Like, it's, you knew exactly what you're doing, you just wrote it backwards. So like, don't stress. All right, this one, arc cosecant, I'm gonna say the same thing as I did in number 11. Flip it over. What's your reciprocal of cosecant? Good, arc sine. And if you reciprocate this, you're going to get square root of 2 over 2. So again, this is one where you probably could do it in your head, but just draw me a triangle anyway, because I'm going to count that as the work. It's positive, so quadrant 1. And so what's our answer? Pi over 4. All right, last one like this, and then we're going to move on to these ones that aren't on the unit circle, where you have to like sometimes do Pythagorean theorem for them. All right, this one's square root of 3, and it's cotangent. Also, it's negative, so that would be quadrant 4. And I'm going to slide the paper back up here to look at our little notes to ourselves. Here's our square root of 3. If you take that backwards, it's going to be this. Cotangent is x over y. So the x is the square root of 3 over 2. The y is the 1/2. Are you guys following me here? I know it's like same thing over and over again. I'm probably putting you to sleep. So x is square root of 3 over 2. Y is a half. And the 1/2 gets the negative. So your angle is pi over 6, but your answer is negative pi over 6. And if you're like, hey, that's literally the exact same triangle and answer we got for this one. Yeah, and if that happens on your test, these are very, very, very redundant. There are so few answer choices, like you get the same thing over and over again. So like, don't second guess yourself if you get the same answer in the same triangle for a bunch of them. That's the way it is. All right, there are 2 questions on the test that you don't have to show any work for, and they're the ones that look like this. Do you see how it's tangent of arctangent? What happens to those? They cancel and you would just get 2/3. So look at this one, cosine of arc cosine. They're inverses. They undo each other. You would just get negative square root of 5 over 7. Now, if the inverse function's the one on the outside, you can't get away with that. Do you remember we had that conversation? I don't know, probably put you to sleep then too, but we did talk about it. So it only works if the inverse function is the one on the inside. If it's the outside, you're gonna have to draw a triangle. Sometimes two. Actually, I think we're gonna have to draw 2 triangles for this one. So start with this inside part. What quadrant is 5 pi over 4 in? Think back to your unit circle, 5/4. 3, good, draw a triangle in quadrant 3. Your reference angle is pi over 4. And so both of the sides are square root of 2 over 2, except what? They're both negative, perfect. So that's like the work. Now we answer the question. Sine is the y value, which you kind of can't mess it up because it's the same thing. So you get negative square root of 2 over 2. So this part that I have circled here is negative square root of 2 over 2. So this is now what the problem is. It's a 2-part problem. We did the inside part, and now we're going to do the outside part. So arc sine can only be in quadrant 1 or 4. Since this is negative, it has to be in 4. And the angle's still pi over 4, but how did you have to rotate to get there? Backwards. So your final answer to the whole thing is negative pi over 4. So again, do the inside part. We got negative square root of 2 over 2. And then we did arc sine of that. So we did the outside part. Same thing for this one. If you were like, hey, I need another example of that, we're going to do it again. 4 pi over 3. What quadrant is 4/3 in? 3, again, 3. And your reference angle is pi over 3. The denominators are just going to match. What goes across from that? Good, perfect. Square root of 3 over 2. That means the other side's a half. They're both negative. And then you answer the question. Remember, that's like the work. Then you answer the question. It says cosine. So cosine is what part of that? X, good, the negative a half. So this part I have circled here is negative a half. So now we're looking at arc cosine negative a half. So do the inside part, and then you're going to do the outside. So arc cosine, and it's negative. What quadrant would that put us in? 2, good. So the negative a half is the x value. That means this is square root of 3 over 2. If you feel like you're writing the same thing over and over again, it's because you are. Embrace that. It's good. It makes life easy. Just do the same thing over and over again. Angle is pi over 3, but your answer is how much you rotated to get there. So how much did we rotate to get there? 2 pi over 3. Perfect. Keep calm and know the unit circle. All right, again, we're going to start with the inside. I would put the 4 over 1 because it's going to have to be a ratio. Remember, like opposite over adjacent and stuff like that? Opposite, adjacent, hypotenuse, right? It's positive, so we're in quadrant 1, which, like, thank goodness. Cosecant is the reciprocal of sine. So sine is what over what? Let's get that first. Sine is what over what in your, like, SOHCAHTOA thing? Opposite over hypotenuse. So this is going to be hypotenuse over opposite. We just reciprocated it. And then you have to do Pythagorean theorem to get this other side. I'm going to call it A. You can call it X. You can call it whatever you want. A squared plus 1 squared equals 4 squared. So that's going to be A squared plus 1 equals 16. So A squared equals 15, and then you have to square root that. So square root of 15. So that inside part that we just did, that represents the angle. That's theta. And now we're going to do secant of that. Secant is the reciprocal of which one? Cosine. Cosine is adjacent over hypotenuse. So if you reciprocate that, it's going to be hypotenuse over adjacent. So 4 over square root of 15. And then that will rationalize to be what? Perfect. You can write on the margin of your paper if you want to. I don't know if this will help, but do you remember whenever we did these and we had like opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then the other three, you're just going to flip them? I don't know if that helps, or if you just have them memorized, whatever. Just throwing it out there. All right, start with the inside part. Arc cotangent, and it's negative. So which quadrant is that going to be in? 4, good. Cotangent would be x over y, or adjacent over opposite, however you want to think of that. So the 5 is the adjacent. The negative has to go with the 12. If you just know this one, we won't have to do Pythagorean theorem. Perfect. 5, 12, 13. The other one you should know is 3, 4, 5. All right, so that represents the angle, and we're going to do cosine of that angle. So cosine is adjacent over hypotenuse, so 5/13. And then we have these ones with u in them. We're going to assume u is positive, so we can put it in quadrant 1. Also, just like with number 20, I'm going to put u over 1 because it's going to have to be a ratio. So draw your triangle in quadrant 1. And tangent is opposite over adjacent. So u is the opposite, 1 is the adjacent. When you do Pythagorean theorem for this, the most common mistake I get is that people try to simplify it. Just do nothing. Like, just don't try to simplify it. Just whatever you get, leave it. It's going to be u squared plus 1 squared equals c squared, or whatever you want to call the hypotenuse is fine. If you want to call it x, you can do that. And so 1 squared is just 1. And to get c by itself, what would you have to do? Get square root and just leave it alone. Like, that is just fine. Don't discriminate. It's a great answer. Like, just don't do anything to that. So that represents the angle. And now we're going to do cosine of that angle. So cosine is what over what? Adjacent over hypotenuse. So that would be 1 over this weird square root. And yeah, we are going to have to rationalize it, and it's going to look messy, but it's just going to be square root of all of that over all of that stuff. Kind of like when you get square root of 3 over 3, it's just instead of 3, it's u squared plus 1. Just go with it. It's the generic form of that. We'll try another one of those. Again, assume u is positive, because we don't know what u is, so we just want to put it in quadrant 1. So sine is opposite over hypotenuse. So 5 is the opposite, u is the hypotenuse. We're going to do the same thing. You have to do Pythagorean theorem. Whatever you get, just leave it, okay? I'm going to call this a. You can call it whatever you like. A squared plus 5 squared equals u squared. So 5 squared will be 25. And then what? Yeah, subtract that over. And then you have to square root. So it'll be square root of u squared minus 25, which is great. Just leave it alone. This represents the angle. And now we're going to do tangent of the angle. So tangent is what over what? Good. So it's going to be, I'm going to write it over here so I have more space. 5 over that nasty square root. And so it's going to rationalize to be what? Square root of all that, right, over the same thing. Perfect. All right, so these are all going to be right triangles. So this one is about the boat being pulled in. So your boat is down here. This is the water. You don't have to draw a boat. Like, I'm just doing that to help you visualize it. The rope is 20 feet long. So where does the 20 go? If that's the rope connect, good, the hypotenuse. That's the rope connecting to the boat. What is the angle of elevation? I just always call it X. You can call it theta, you can call it A, call it whatever you want. The boat is 16 feet away from the dock. So where does the 16 go? The vertical or the horizontal? Good, because it's 16 feet away. And then you just have to make the decision, sine, cosine, or tangent. It's based on this right here, your SOHCAHTOA. So which one? Cosine. Perfect. Cosine of X equals 16 over 20. You're going to type cosine inverse and do 3 decimal points. And make sure you put degrees. I know it is a silly little thing, but it counts as the units, and I make the units worth something. So if you don't put them, then I have to take off for that. So just please put the degree symbol. Or if you think you're going to forget, write out the word degrees. Like if you really feel like you're going to forget, like just write it out in word form. All right, 25, go ahead and draw a right triangle. A man is standing 22 meters away from the building. So where would the 22 go? Yeah, horizontal, because he's 22 meters away. The building is 58 meters tall, so that's going to be the vertical. What is the angle of elevation? So sine, cosine, or tangent for that one? Tangent, good. Tangent of X equals opposite over adjacent. And then we're going to type it in with tangent inverse. All right, and then last one, a child looks down at his friend from the top of a jungle gym. So they're playing at the playground. Find the angle of depression. This would be the angle of depression, but it's congruent to the angle of elevation. So you could just put X down here at the bottom if you want. Let's see, if the jungle gym is 15 feet tall, so where does the 15 go? Vertical. And they are 17 feet apart. So one friend is up here on the top of the jungle gym. The other one is down here. They're 17 feet apart. I wanted to do like one of each, like this one's cosine and tangent. So this one's going to be sine. I had to get the hypotenuse in there somehow. So sine of X equals 15 over 17. And then we're going to type it using sine inverse.